Welcome to Brain Vision.
Okay, so we're going to look ahead at this problem. I've just drawn the circular loop with the current clockwise as given. So it says we're looking down the negative z-axis, so that means that the positive z-axis is pointing out of the page, and we have the x and y coordinates just as these. These are somewhat arbitrary, but I just drew them anyway. Okay, so the first thing we need to know is what is the vector magnetic moment of this? Well, so we know that the magnitude of magnetic moment is equal to the flow of current times the area of the loop. But of course, we need to know the direction for the vector. So because the loop points in the xy plane, the normal vector to this points along the z-axis. So it will either be plus or minus the k-axis for this. We just need to determine which one now. And so actually that's kind of simple because if you know your right-hand rule, you know that in order to determine the direction, if I curl my fingers in the direction of the current, my thumb will point in the direction of the magnetic moment vector. So although I can't do this on the recording, if I curl my fingers in the direction of I, that means that this points into the page. In other words, it points in the minus z direction. So for part A, it's just equal to I times A times the minus k hat vector. So that will be my solution for part A. Okay, so using the result from part A, we can now use some of the other information given in the problem. So, for example, we know that the torque, which is provided by the magnetic field to this magnetic loop, has the following form. It has the form some constant d times 4I minus 3j. Well, we also know that we can write the torque on a magnetic moment due to a magnetic field as the vector magnetic moment cross with the vector magnetic field. And of course, well, we know what this first part is, we know what this is, and so that will allow us to solve for information for the magnetic field. Now, we don't know what the individual components are, but that's fine. Let's just write this out. So I have, in this case, I have minus IA k as my vector for the magnetic moment. And I'm just going to write this out as bxi plus byj plus bzk. And now if we remember the vector identities, if I take k cross I, that will give me j. So if I'm going to write this out, this will give me minus I a b x, and that will give me the j direction. And when I do k cross j, that will give me minus I hat. So I have minus and minus, so that gives me plus I a b y in the I hat direction. And of course, k hat cross k hat will give me nothing, so I can't actually determine bz at this point. But well, let's make the connection then between this form and the form up here. So I have minus IABX as this j component, and I have positive IABY as this I hat component. So then I can go ahead and I can write out that IABX is equal to 3D, which of course then will give me that BX is equal to 3D over IA. And I can also write IABY is equal to 4D, which then will give me that BY is equal to 4 times d over IA. So here are two parts of what we need in the end, but we still have to determine BZ. And the way we determine BZ is using the other piece of information that the magnitude of the total magnetic field is equal to 13d over IA. So, of course, the magnitude of a magnetic field, like I say, the square of the magnitude of the magnetic field is equal to the sum of the squares of each component. So I can write it as, break it down into these pieces. But of course, I know what B0 is. I now know Bx and By, so I can use it to determine Bz squared. So Bz squared is equal to B naught squared minus this. Okay, so I have to square the terms and then add them appropriately. This will give me 169 d squared over I squared A squared minus, and then in here I'll have 3 squared, so 9 plus 4 squared, 16. So this will be 25 d squared over I squared A squared. And well, nicely, that will work to this nice value. And so therefore, when I take the square root to get BZ, I will get BZ is equal to, well, the square root of 144 is 12, and then the squares just go away. So this will be equal to 12d for IA, but because I took the square root, I have to consider both the plus and minus options. So we have to determine which of these is true. Is it plus 12d over IA or minus 12d over IA? And the final piece of information that the problem gives us is that the potential energy, which is equal to mu dot B, that this thing is less than 0. Well, if I now rewrite this knowing what I know, right, I know that the magnetic moment points in the minus direction. And so, well, if this whole thing is negative, then the part in red is positive. So that is the BZ component points in the same direction as the mu Z component. And well, since the magnetic moment points in the negative Z direction, that must mean that the BZ component points in the minus Z direction as well. And so finally, right, I can use that to add the last piece of information. So it has to be the minus 12d over IA. And that will give you all the components that you need for the problem.